Okay. So did you guys have like a notification, like allow recording? Can anyone verify that?
Yeah, we got that.
Okay, awesome. Okay, yeah, sorry about the delay. So I think we have everything ready now. Okay, so yeah, this is the course, Medical Image Computing for Spring 2022. First of all, Happy New Year. I hope you guys have a wonderful winter break. So welcome back to the new semester. My name is Chen Chen. I'm an assistant professor at the CRCV and also with Department of Computer Science. So I'll be teach this course today. Let's see, this is the right one. Okay, so are you still see my screen now?
No,
No.
you just stopped sharing.
Oh, okay. So is it already broke up? Okay. Let me share that again. Okay, so it's visible now, right?
Yeah.
Okay, thank you. So for today's class, we'll just go over the syllabus, do a quick introduction about the course. So first of all, a bit about me. So I joined the UCF last fall, so fall 2021, and this is my second semester. I was assistant professor at ECE at the UNC Charlotte for the past 3 years. So my research is focused on computer vision, machine learning, and image video processing. So here for this slide, I kind of highlight a couple of some representative work for my research group. So here we do a lot of video analysis that is focused on action detection, action recognition, video object segmentation. And here we also have video anomaly detection. So which is you want to detect some of the anomaly event that is in the video. We also do object detection in images, specifically in this kind of aerial image. So there's some challenges for like aerial image because of the small scale of the object. And we also do human pose estimation reconstruction. So you have an image, you want to reconstruct the pose. So here has a lot of applications in AR and VR, right? So if you see a lot of gamings, you want to, estimate the human pose or gestures so you can interact in the world, in the game. And for the machine learning side, we do research on efficient deep learning. So as we all know, deep learning is kind of triumph all fields, right? But one big issue for the deep learning is that it's very, data and power hungry. Sorry, so you need a lot of compute resource to achieve a very high accuracy for your task. But nowadays we have a lot of edge devices like the cell phone, maybe drones or smart cameras, right? How are we going to deploy this kind of large model on these small devices? It's not possible, right? So we want to come up with some solutions to cope with that. So can you devise an efficient deep learning framework that is able to run on these kind of resource limited, platforms? And also we have robust machine learning. So there's a very hot topic that is adversarial robustness, right? So if you make small changes to your data, for example, images, then the machine learning model can fail, right? So there is some brittleness of the machine learning model. We want to make it more robust so that, is able to, do some practical deployment for some real world applications. And there's also federated learning, which basically is like a privacy preserving, machine learning paradigm, which is going to be a one topic for this class, because we are dealing with medical images. There's a lot of, patient privacy issue, so how we are able to learn from, data resides in different hospitals without sharing the data, right? So that's a very trending topic we want to touch upon in this lecture. Okay. Since this is a medical image computing course, so I also have some ongoing or active projects that is related in this field. So we did see if I can make this go away. Okay. So we have this efficient 3D convolutional neural network for brain tumor segmentation. So the brain tumor segmentation for the MRI is very popular in medical image computing. But these 3D CNN network is very computation and memory heavy. So it usually requires a lot of resource and maybe take a very long time to process MRIs volume. So we want to develop like a lightweight and efficient neural network that is able to very compact, require a lot less memory overhead, is also very computation efficient. And this is our recent work in the MICAI 2021. The same topic, that is, we do this MRI, brain tumor segmentation, but we devise a new type of neural network architecture that is a hybrid architecture for CNN and transformer. So which we'll also talk about, like the most recent transformer architecture in Vision Task. This is another one that is also for the segmentation for this myocardial pathology segmentation. So basically you want to classify these myocardium into different regions. So this is for the MICAI 2022 workshop. And this one is for the malaria life cycle classification. So malaria is a type of disease that is, the parasite, infect the mosquitoes, and if the mosquitoes feeding on the human, then you got infected, right? So it's a transmitting disease. People can get really sick, high fever, etc. So we want to, for this project, we aim to examine this blood thin smear image. So basically, we want to detect those red blood cell from the image, and then try to classify, is this a healthy red blood cell, or maybe it's already been infected by the malaria. And after that, right, so we detect those, each of the cells, then we also classify, which life cycle stage for this malaria is on. So there's a 4 or 5 stages. So we want to do this kind of five class classification. So we also kind of converting the entire pipeline and make a web, app. So people can using their cell phone, especially for developing countries, they don't have the luxury to go to the clinical or hospital to do the examination. But if we're able to make an app, right, maybe they have this image and they can take a picture, and we can run this AI or machine learning algorithm to provide this kind of diagnosis result, and immediately give them the feedback, right? Are you infected, or what kind of stage are you in? So that's what this work was done. Okay, so that's some very brief background about myself and my research. So I think it will be good, for us to know each other since we have about 28 students. So maybe we can starting to introduce yourself, right? So your name, then, are you a master or PhD student, and do you have any background knowledge in these fields, right? Image processing, computer vision, deep learning. So this will also help me to learn, better about you, so I can maybe adjust some of the content for my course lecture. So based on the knowledge you have in these kind of different fields. Okay, so maybe so we can starting to like I'll just call the name one by one, or if you want, you can. Why this is going? Sorry about that. So maybe I can go from here one by one. Kyle Bags, did I pronounce your name correct?
Yeah, that's right, Kyle. Yeah, so I'm a graduate student actually in mechanical engineering. My research has to do with computational fluid dynamics, so simulating the blood flow. So I have a lot of interest in segmenting out the vessels so I can actually compute simulations on them. And I have a little bit of experience with deep learning, mainly these UNet architecture, just in practice a little bit, just for application.
Okay. So I guess your motivation for this class is clear, right? So since you do some similar work in your research, maybe you want to try this class and maybe learn something from here. Is that correct?
Yeah, that's right. And I want to try to bring the two sides together. So hopefully it's just one pipeline. You get the MRI or CT, whatever it is, and then you can just one pipeline go straight to simulating on it.
Yeah. Okay. All right. Great. All right. Thank you. Next, Zach.
Me?
Yeah. So sorry, I may pronounce your name incorrectly.
Oh, that's
Yeah,
fine.
would you mind,
It's
like,
Zacchaeus, Zachy for
yeah.
short.
Okay.
So I'm a CS PhD student in the computer vision Center for Research in Computer Vision group under Dr. Shaw.
Okay.
My background knowledge, so in undergraduate, I did research on doing exoplanet measurements with Spitzer images. And since I've become a grad student, most of my work has been in the DEVA research group dealing with real-time action recognition. And then I guess other background is just various computer vision and machine learning courses I've taken. And I would like to move more towards like EEG, brain-machine interface type research is where I'd like to go moving forward.
Okay, cool. But I'm not sure if I will, get touch upon on that. But definitely, we have some, component built into this course that you can actually learn some of the topic you are interested in, which I'll, introduce later. Okay. But thank you for your introduction. All right. So let's move on to Sarah Kumar.
Hello, Dr. Chen. This
Hi.
is Sarath, and I'm a master's student in computer vision. And I have background in computer vision courses, CAP 5415, and machine learning courses I have taken in the fall semester. And I am also sometimes working in the NGA project that you generally work with under Dr. Shah's group. And that's it. That's what.
Yeah. Okay. Yeah. Thanks, Taras. So yeah, we have a lot of meetings last semester. So yeah, thanks.
Yeah.
All right. So next, Tululope. Yeah, please correct me if I didn't pronounce your name correctly, and don't take that as offense. I'm sorry about that.
Hi, Professor. My name is Tolu, and I am a CS major. Wait, I'm not undergrad. I'm sorry. I'm master's first semester. I feel so unqualified compared to the rest of them, but I don't have any background in any of the topics. But I'm really excited to learn.
Yeah. Okay. All right. Thank you. Next, see here. Nikhil.
Yes, that's correct. My name is Nikhil Sridhar. I'm a junior in the computer science program right now. And I actually don't have any background knowledge in any of those topics as well, but I have a huge interest in all sorts of like machine learning applications, especially when it comes to like image processing.
Mhm.
I actually plan to do a bit of research either this summer or during fall, maybe alongside a senior design project. But I wanted to take this class to kind of like branch out. You know how machine learning is a very vast
Yeah.
subject. It has a lot of applications, whether it's medical or like automotive or any application. That's why I just wanted to like take this class to kind of branch out,
Yeah.
see how this applies to the medical industry.
Mhm. So you are undergrad student, right?
Yes, I'm a junior right now.
Okay, so have you decided your senior like design project yet?
I haven't gotten that far yet,
Okay.
but I hope it can be something to do
Yeah.
with like
Yeah,
machine learning.
yeah. I think that's a good direction. So maybe if you learn something very interesting, then you can think about maybe kind of take what you learn from here, or maybe some of the course project, maybe eventually turn that into your senior design project. Yeah.
Yes, definitely.
Okay. Okay. Cool. Then Tao.
Oh, yeah. Hi, everyone. I'm a PhD student in CS department. Actually, I'm a PhD student of Dr. Chen. Yes, I mainly work on the efficient deep learning, like how to design efficient neural networks and how to design better learning method to learn better representations. And I also work on some computer vision applications. Yeah, basically that's it.
Okay, all right, great. Thanks, Tao. Next, Matthias.
Super close. My name is Mateus Urbanski.
Okay.
I am currently a MS student in the computer vision program. Aside from academics in like computer vision and all the courses I've taken, I have done a personal project with MediaPipe, having done some hand gesture implementation. No research, but I'm currently in industry working research and development with Abbott. They don't really do much computer vision. However, they have talked about some spec work with it. So maybe this is just an interesting class to me, and it's part of the curriculum. So yeah, I'm excited to learn.
Okay, wonderful. Yeah, thank you. Then next, Crystal.
Hello, I'm a master's student in computer science. My current project is pose and action detection in animals. I don't have a very strong background in computer science or computer vision. I worked more on the biology aspects, which is more of what my project is geared towards. It's for conservation biology.
Yeah, I think maybe the pose estimation from animals you mentioned, maybe that give you at least some background knowledge or experience in computer vision. So yeah, I think that's maybe a good starting point. Yeah, this course may give you some extra knowledge in terms of medical image processing. Okay. All right, so next, Joe.
Yeah, hi, this is Joe Rivera. I'm a part-time master's student in the computer vision program, and I'm a full-time research engineer at Lockheed working on deep learning and computer vision problems.
Okay, great. Thanks, Joe. Yeah, there's another Joe here. So let's go to Joe Fioresi.
Yeah, that was actually right, Fioresi.
Yeah.
So I'm an undergraduate senior in computer science. I actually participated in the computer vision RU under the CRCV. And so I do research doing semantic segmentation of solar panel defects.
Okay, great. Yeah, so one part of this course we'll talk about the segmentation of medical image. So I think, basically the technology for the natural image segmentation applies here for the medical image as well. So I think that will be a very good background knowledge here. Okay, thank you. Next is it Akin? I must pronounce your name wrong. Sorry.
No, it was close. Ilkin.
Okay.
Yeah, I'm
Okay.
a CS PhD student, and currently I'm working on medical image segmentation with Dr. Baja from Northwestern. We are working on some like CT images of cancer patients, mostly head neck data set and lung data sets. And I'm currently trying to add some like uncertainty quantification to the segmentation right now.
Okay.
And yeah, that's it.
Okay, great. So I guess you are like already in this field, right? Already doing a lot of
Yes.
medical image segmentation. Okay.
Right.
Okay, awesome. All right, thank you.
Yeah, thank you.
So I think, yeah, is Umar?
Yes, it's Umar Khalid. Hi, everyone. So I'm a PhD student at UCF, PhD computer engineering. I'm working right now in applications of deep learning for RF and wireless communication. Before that, I have been working in different areas like object detection and segmentation. So why I'm interested in this course is because before joining UCF, I was engaged with a startup in Shanghai, and they were working on medical imaging. And basically they were using traditional Chinese methods for smart treatments of the patients. So I learned a lot over there while working as an R&D engineer. So over here on this course, I want to explore more and want to expand my knowledge, and especially want to find more applications of deep learning and computer vision.
Okay, all right, great. Yeah, I think you have very interesting background, also has some working experience. I think that's pretty good because that give you some of the, inspirations. Maybe you can come up with some new ideas to solve the problem, which, could potentially be a, project for this course. Okay, all right, thank you. Next we'll have Tenjib.
Hi, I am a PhD student in the Department of Mechanical Engineering. So my research focuses on using cardiac MRI data to do segmentation of the cardiac cavity and the myocardium and the ventricular portions. So I want to I guess I'm taking this course to learn more about different image processing techniques that will help me to do the segmentation. And I also want to build a deep learning network that will help me to automate this segmentation, where I could use the MRI data as an input and then just get the segmentation as the output.
Okay, all right, great. I think another student from mechanical engineering. All right, thank you.
Thank you.
Okay, next we have Ryan.
Hello, so I am a first semester graduate student of computer science, although I am looking to transfer into the Masters of Computer Vision program. So I have a very strong background in software development, not so much in computer vision or deep learning yet. I have taken CAP 5415. That was a very interesting course. And I'm not involved in any research right now, but I am looking to get involved when possible.
Yeah, great. Yeah, I'm glad you are another student for this Master in Computer Vision program. So definitely, I think you have the choice of being like purely taking the courses, or maybe later you want to have like a thesis-based master, right? So if you find something interesting or you got inspired by this course on doing the research, and definitely you can think about maybe go for this kind of thesis-based master. Okay.
Yep.
Yeah, awesome. All right, thank you. Next we have Brian
I'm a computer science master's program student as well. I spent most of my life and experience working with front and back end web technologies. So I'm really just taking this course as one, to help complete my master's, but two, it's something I've never even heard of really. So I like to expand my horizons to learn the different types of CS technologies out there.
Okay, great, thank you. Next we have Matthew.
Hi, I'm a new graduate student in the computer vision program. I actually come from a background in finance, and I want to explore a new field and see where it takes me. I'm not sure which area I want to focus on just yet, but I'm open to learning, and I'm hoping to learn as much as I can in this class.
Yeah, okay, great. Yeah, it's interesting to have a finance background, but I think, you know, in terms of machine learning technique, you know, if you later decide you want to go back to finance, maybe some of the machine learning technique you learn can also be applied there, right? So yeah, I see a lot of, you know, physics background, you know, and computer science background graduates, they, you know, they eventually go to the finance, you know, field. Yeah. Okay, think Alina.
Hi, this is Alina Khan. I'm a PhD student from the Computational Imaging Lab. I'm working with Dr. Hassan Farouche. Right now, I'm focused on adversarial attacks and defenses. I don't have any prior knowledge with medical image processing, but I'm interested to learn. That's why I enrolled in this course. But I do have background knowledge about image processing and computer vision and deep learning.
Yeah, great. Yeah, I think when you do this adversarial robustness, you know, in this field, a lot of applications for computer vision, right? So how you can design, detect, I mean, the attack algorithm to make your machine learning model fail, you know, for image classification, object detection. On the other hand, you also want to, you know, develop a defense mechanism, right? To make your machine learning algorithm more robust to such of a attack mechanism. Okay, great. And also definitely adversarial robustness is going to be one topic for this course as well, because, you know, medical imaging is very, very crucial, right? If your machine learning fails, then you make a false diagnosis, then that's going to be catastrophic, right? It's going to be, you may leading to the death of the patient. So that's very serious. So yeah, that's definitely one very important topic.
That sounds interesting. Thank you.
Yeah. All right. Thank you. So next we have Michael Fielder.
Can you hear me?
Yeah.
Oh, hi, my name's Michael. I'm currently enrolled as a master's student in the computer vision program, and I've only taken introduction to computer vision as of now, and I would like to do research in the future whenever possible.
Okay. Yeah. Yeah, great. So I think, Introduction to Computer Vision is a very good course. So you have some background knowledge in this field, at least to help you quickly, you know, if you want to do some medical image processing, a lot of technique can be applied here. Okay. All right. So next we have Parker Scott.
Hello. My name is Parker Scott. I'm a master's in computer science. It's actually my final semester, hopefully. And as far as background knowledge, a lot of my knowledge comes from video game development or VR development. For image processing, I've used a lot of Perlin noise for procedural generation of land and terrain. And as far as computer vision, I've worked with the Microsoft Kinect a lot for something similar with pose detection and things like that for detecting walk cycles to be able to move within the virtual reality.
Yeah. Interesting. So, you know, in healthcare, Medicare, you know, people starting to also use a lot of AR, VR technique, right, to train a nurse or train the physician to do the operation, right? So, yeah, maybe there's something interesting, you know, you can combine with your background, maybe develop something, you know, that can run in this kind of for the AI or VR application, right? So yeah, interesting.
Fortunate.
Yeah. All right. Thank you. All right. Well, next is going to be a hard one. El Genju.
Alejandro, it's okay. I'm a don't worry. I'm a master's student in computer science. I have background. So in undergrad, I took robot vision, and then for my senior design project, I developed the computer vision pipeline for an autonomous drone. And then last semester, I took intro to computer vision, and then this semester, I'm taking an advanced computer vision.
Mm-hmm. Okay, great. So you have a very good background in robotic vision. Okay, awesome. I think we come to the last student. Is it Casson?
Oh, yes, Professor. I'm from math PhD program, financial math. And honestly, like I don't have a background, but I'm looking forward for the class. But I have a little issue too, because like this is my 4th class and my department told me that there's a requirement too. So I'm gonna meet my graduate advisor again. But I have done some background research and I really want to take this class, but let's see.
Yeah. Yeah, okay, great. All right, thank you. So I guess I have everyone here, right? But did I miss anyone? Please, feel free. Okay, so in that case, I think we, we all interested ourselves. So I know a little bit background on everyone's, where you guys are coming from, why you are guys interested in taking this course. So for this, the rest of the lecture, I'll just briefly talk about what this course about. So hopefully after this course, you can, re-examine, if this is the course fits you, right, fits your needs, and you can later decide if you want to stick around. Okay. All right. So so a few logistics. So this is a highly interdisciplinary course, right? So we have image processing, computer vision, and a heavy part, it will be on machine learning, specifically deep learning. And this is the lecture time. So I see most of you guys are here. So assuming you guys read the syllabus and know the Zoom link, that's no problem finding where the class are. And so office hour, right now, I haven't decided yet. But you can email me for appointment, but later if I see there's a lot of requests, especially maybe before maybe your programming assignment is due, or you have any questions about your project, I can host online office hours so you guys can join, freely ask questions, okay? But for now, if you have any questions, feel free to send me email so we can, set up a time to meet. Okay, so once again, this is the Zoom link. So please, you can save this in your calendar. So when it's time, you can click the link and join the Zoom meeting. Okay, for this course, we'll heavily using Canvas, the web courses at UCF. So I will send in reminders, notifications, like I'll remind you for the homework due. And if I have sent out some notifications or announcement, I will be sending from there. Okay, you should be able to receive email from there. I will also post course materials. So the slides for this course is already being posted on Canvas. So feel free to go download that and check that out. And after each course, I will upload the recorded lecture videos. So if you miss something or if something is not very clear, you can go back and watch the lecture videos. So I think that would be good. And also we'll submit reports and assignment. We'll also have some places for discussion, right? If you have a project you want to discuss with your classmates, maybe there's a place for you to discuss there as well. Okay. Okay, so I'm assuming you guys are familiar with Canvas, right? So this is our the page for the course. So mostly we'll check like announcement assignments. So all those assignments will be there. syllabus. I encourage you to, of course, I will go over the syllabus, but after class, I encourage to look at the syllabus again to make sure you know what's the expectation and some of the requirement there. Okay, and the module here will post like the lecture slides and the videos. Okay. Okay, so next we'll go over the syllabus and discuss a couple of key components. So for this course, we don't have a required textbook because this field is evolving very quickly. So especially for this kind of deep learning technique. So we will mostly stay with the recent research papers. Know what's the state of the art, and I will incorporate that into the course lecture. And we're also reviewing papers, so we know what's the the state of the art in this field. But aside from that, I list a couple of like a supplemental textbook. So for some of the concept or classical techniques you are interested in, maybe these are very good reference books you can go for. Okay, so there's a medical imaging. And also there's a few popular books on machine learning and deep learning. Okay, so some of them actually are freely available, like online. They have a like electronic version. Okay. Aside from these references of textbooks, I also have a couple of recommended resources. One is the course from Stanford. So this is probably the best popular course for deep learning or specific convolutional neural network for visual recognition. So there's a lot of fundamentals, like CNN and other, a lot of popular neural network architectures has been discussed, and also a lot of computer vision tasks like object detection, semantic segmentation, visual question answering, those topics are being discussed in that course. So you're welcome to check that course as well. And this theories of deep learning, I think it's from Stanford as well, by David Donahoe. So he's the one heavy hitter in the statistical department. So he has this course for talk about the theories of deep learning. So if you are the guy more interested in theories of deep learning, so maybe this is a good course to check out. Okay. And of course, Dr. Yogesh from CRCV, he has this computer vision course, CAP 5415. So all these course materials and some lectures are available on this website. So you are, encouraged to check those out if you don't have any, prior knowledge or background in computer vision. Okay, so the last one is the Python for computer vision. So basically, this is like a guideline or tutorials for using Python programming for computer vision. So if you not familiar with Python, maybe this is a good textbook for you to check it out. Okay. Also, here is I listed a couple of video resources you can find on YouTube. So the Computer Vision Foundation, they have a YouTube channel. So they post the latest videos or talks, tutorials hosted by the conference. So CVPR, ICCV, and ECCV are the top conference in the computer vision domain. So this channel hosts all those videos, tutorials, and talks. So you can actually browse these. If you're interested in medical image segmentation, they may have some relevant tutorials there. So you can check that out. So I don't know if other conference like medical image computing conference like MICAI they will have, but because of the last 2 years, because of the pandemic, these conferences are held online. So I'm assuming there's going to be a lot of video resources for medical image computing conference on MICCAI. But yeah, I'll check that out. If I found, I can send you those information. Okay, but the point is you can find a lot of information resources from YouTube. Okay, there's also a couple of conferences and journals to follow in this medical image computing field. Of course, we want to follow the top quality conferences and journals. So for the top tier conferences, they all have this kind of double blind review process. Basically means when you are the author, submit the paper, you don't put your name and affiliation. So the reviewer don't know who are the authors. And the same, you don't know who are the reviewers. So that's called a double blind. So just to make like a very subjective judgment for the paper. And the acceptance rate are very low, typically maybe below 25%. Some conference can be lower than 20%. So they are very high technical, high quality technical articles. So for medical image computing, probably the flagship will be MICCAI, stands for Medical Image Computing and Computer Assisted Intervention. And there's another one is IPMI, Information Processing in Medical Imaging. So these are like the well-known, well-established top tier conference in medical imaging. There's also other conferences which are also pretty good. International Symposium on Biomedical Imaging, EMBC, International Conference on Image Processing, SPIE Medical Imaging. So these are other very good conference, but they may not as good as these two. Okay. There's also some other clinical conferences. They may not very focus on technical stuff because they may more emphasize on the clinical side, right? Maybe those are published by physicians, right, in the hospital. They have a lot of patient data, do some clinical trials, and have some findings they publish here. Okay. There's also general vision and machine learning conferences. So these are like a specific conference, in the medical image computing field. But the general conference like CVPR in Europe, ICML, machine learning, learning representation, ECCV is European Conference on Computer Vision. ICCV is International Conference on Computer Vision. So, you see it all has some, keyword computer vision or machine learning there, right? So medical images is no exception, right? Because right now there's a lot of computer vision and machine learning techniques has been applied, in medical image processing. So on these conference, general CV or machine learning conference venues, you will find people from medical domain and publish papers, high quality papers on these conference venues. So, and we will talk about discuss a couple of papers, in this course that they come from CVPR or ICCV. So these are the conferences. So for those you don't have any experience in publishing papers, so usually people go for a conference because the short turnaround, right? So usually, if you have a very good idea, you do some prototyping, get some result, and you can publish into the conference just to kind of let people know, okay, you have this great idea, right? And later you can, do some further development, then publish, have a very comprehensive evaluation, then you can eventually go for a longer version, which is the journal version. So that's typically people or researchers will do, right? They first go with the conference just to let people know this is their new idea. Then they do more analysis. Then they go for the journals. So for the journal, there's a IEEE transaction on medical imaging. So that's the flagship journal for medical image processing. There's also a transaction on biomedical engineering. And this is the, this is a general in the computer vision and machine learning, that is transaction pattern analysis and machine intelligence, PAMI, and also transaction on image processing, right? So actually this journal also have a lot of, works that is focused on medical imaging, right? Because it's a general image processing journal. There's also, so these are from IEEE, so that's the publisher. And these are from another publisher. So medical image analysis, CMIG, and the neuroimaging. So these are very top quality technical journals. There's also some clinical journals relevant to medical image computing. So again, they may emphasize on the clinical findings, not purely like technical stuff, right? But maybe these journals, they are focused on the technical stuff, content, right? You have a novel method, but here maybe they just apply some existing or state-of-the-art method, but they have some clinical findings. Okay, so they have maybe have different emphasis. Okay, of course we have this archive and also like a bioRxiv that is for medical imaging. So this is not peer reviewed, means if you have some idea, you can write a report and you can, you don't have to submit to anywhere. You can just post on the archive, which right now, in the computer science, in particular, in the machine learning field, people always first publish their paper on archive just to secure their position on the idea, right? Because a lot of people working in this domain, I want to protect my IP, right? So there's the way to, in order to do that, they post their papers on archive while their papers being under review under a conference or a journal. So yeah, so this is like the new normal for the researchers to publishing papers. Okay. Any questions so far? Okay, great. So, and there's here we can talk about a couple of prerequisite and preparation. So it will be helpful if you have some basic knowledge, like from the probability, statistic, and optimization, because a lot of time for this course we'll talk about deep learning. So these mathematical background will help you a lot. Okay. Again, so these are some of the reference courses you can look into to get some of the necessary background knowledge. So I'm not asking you to go systematically to learn the probability of statistics, but maybe when you're reading papers or maybe getting to know some topics, these mathematical background will be useful for you to understand some of the concept. Okay, but you are not necessarily required to learn everything from scratch. Like, that's not possible. Okay. All right. Next will be the programming. Okay. Because we have programming assignment and course project, so so it's necessary you are proficient in programming languages, preferably Python, because we'll do a lot of programming using deep learning. A lot of right now a lot of toolboxes and frameworks, they are written in Python. Okay, so yeah, and next some general knowledge of the deep learning frameworks, PyTorch, TensorFlow, Keras. So I think nowadays PyTorch is widely used in academia, so it's very easy to use and prototype your algorithm. They also have very well documentations for references. So if you don't have any knowledge in these deep learning frameworks, that's fine. So I provide some of the tutorials here, so you can check these tutorials. And even for programming assignment, I may provide some helper code for you, to start with, so you don't like starting from the scratch. And to be honest, there's a lot of code available on GitHub. So basically, you don't have to do something from scratch, right? Like you don't have to program like ResNet from scratch yourself, right? So the libraries has these network architecture already there. So you don't have to do that by yourself. Okay. And this medical open network for AI is a very good resource I recommend to you because we're doing medical image processing. So it's a PyTorch-based open source framework. So they have a lot of modules built in that you can load medical image data like CT, MRI. So just a function call, you can load those medical data. And there's also a lot of modules implemented, like, for example, you can do some pre-processing for your medical image data, like registration, maybe do some denoising, etc. Okay, so it's like everything in one place. So you can just call those functions, then you achieve some of the functionality. Okay, and they also have some tutorials like for medical image analysis examples, like for example, classification, MRI segmentation. So those are like working examples. They can help you, step by step, how you are able to do medical image segmentation, for example. Okay. Yeah, here I also have found a video tutorial recently. They give a very in-depth step by step how you are able to using this tool to accomplish medical image analysis using deep learning. Okay, so for this course, we have a couple of components. Here are the basic requirements. We will reading research papers and writing review reports. So we have 10 papers to review throughout the semester. So each week you will be assigned one paper. Maybe after 3 or 4 lectures, I will post the papers for you to review. So after you review the paper, you will write a review report. So I will provide more details in the next lecture, right? How you read the papers, how you write the reports, what's my expectation. So I will give you very detailed walkthrough how you're gonna do this. Okay, that's for the next lecture. And also I require class participation. Basically when I'm doing deliver the lectures, I may ask you questions. That's to prevent you from falling asleep. And also when student presenting papers will ask you to ask questions, right, about the papers, right? Maybe some point you don't understand, or you have some thoughts or new ideas you want to share with the other students. Okay, and the presentation in the later semester, each student will present one paper. So again, it's a research paper. Then you will basically you will play 2 roles. One is assuming you are the author of the paper and you are giving a talk in a conference, right? You want to introduce your method, the paper ideas to the audience, right? So how you're gonna present your research work. And the second role is you want to put yourself into the shoes of the reviewer's shoes. Okay, like you are reviewing this paper, do you see any weakness or some of the potential ideas that you might able to extend or maybe improve, right? So that's the second role I want you to play when you're presenting the paper. Okay, first is introducing the paper, the method, to the class. The second is think about what are the weakness or strengths of the paper, then what are the ideas you have maybe to improve the paper. Okay. And next is the program assignment. We'll have 3 programming assignment. So the topics I already put it here. First will be deep learning based image classification, right? Like for example, we will do this COVID-19 CT images to classify if this is a positive or negative case. Okay. And second assignment will be image segmentation. We'll using a CT image and segment, do the segmentation. And the third will be image synthesis using GAN, General Adversarial Network, or maybe other technique. So basically, maybe you want using a CT image and using that to generate another imaging modality, say MRI, right? So that's actually a very interesting topic which we'll cover in the course. But I wanted this as an assignment, for you to practice. Okay, so those are the 3 topics for the assignment. Last one will be the individual research project. So it's gonna be deep learning based and also are relevant to the course, right? It has to be dealing with medical imaging, image processing. I will provide a list, of ideas, for you to as a reference to you, right? If you are interested in those topics, you can pick one from those lists. But you can also come up with your own topic, which I will also discuss this in detail in the next lecture. Okay. Okay, so here is how the grading policy. So for the reports, we have 10, so 20%, and paper presentation, 15%, and attendance discussion, which is basically give you like 3 points, right? If you participate in this kind of discussion, then everyone should get, the 5%. And programming assignment, three programming assignment, 30%, and also the final project, 30%. Okay, so this is how the different components account for. Okay. Please do not submit your report assignment late. I know some of the courses instructors, they allow like a few days late as a discounted score. It's gonna be, maybe it's a way to, somehow may encourage you to being late, but for this course, I will not allow late report unless you have a convincing reason. For example, like you are sick maybe, and you have this doctor's note, you can let me know. Okay, so we can discuss that. So all the reports and assignment will be submit in the web course Canvas. Okay, and these are the letter grades. Okay, so for the final project, that's account for like a big portion of your grade. We'll have 3 components. One is the project proposal, which will in the beginning of the semester, maybe next couple of weeks, we're starting this process. Basically, well, what is your proposed project, right? What's the problem statement, and what is your plan, initial plan, right? So I'll also provide some details how to have this kind of thinking process and generate this proposal. The milestone report will be due in the mid of the semester, maybe early April, I think. This is like, you can extend your proposal to the milestone report, right? You have these initial plan. The milestone report is basically track, like how far, how far are you going right now in terms of completing the overall project, right? I know some students, if I don't force this, maybe you will do this in the next, maybe in the last 2 or 3 weeks. That's not good. So the final project is supposed to run like a semester-long project, okay? So by having this milestone, I want to track where you are, right, in terms of the progress. And so basically for the milestone in the middle of the semester, you should at least have some initial result, and maybe you still have some part hasn't finished yet. You can keep doing, finishing that and put in the final report, okay? So the final report is basically extended from milestone, right? What you accomplished or completed after the milestone. So that's gonna be a complete project report. Okay, and we'll also do the project presentations just to let the other student know what is the project you're working on, what is the outcome, some of findings you achieved for this project. Okay, so if you are really working hard and you are able to produce something, if I see there's some valuable things, maybe there's a potential to submit into a conference or journal, I will very much encourage you to do so. And we can sit down and discuss some details, how maybe we can refine it and maybe submit to a conference, okay? So this is the ideal case. I want, there's something you can come out of this project, not just you practice something and, then just leave it there. But hopefully we can have something, come up with something novel and eventually resulting like a publication. Okay, since we are doing, we'll focus on deep learning, I understand the computing resources are very important. So I list here a couple of, free GPU computing resources you can take advantage of. The first is the Google Colab. So it's free. So you can check out these tutorials, how you can use in Google Colab to set up the environment and train your deep neural network. Kaggle is another platform, right? So a lot of competitions run on the Kaggle. So they also provide some free GPUs and the TPUs as well. So you are able to leverage that. So here you provide some of the very useful resources. You can check how to set up the environment there as well, okay? And UCF also have this Newton GPU cluster, okay? So these GPU cluster is made available to all the students and faculties at the UCF. So you can follow the instruction I provided here. So I think you first have to request user registration. So you can mention you are using this for this course. And once you have established a user, then you can submit jobs, like you train your network using this Newton GPU cluster. Okay, so here is another like a general information for how to using this GPU cluster at the UCF. Okay, here are some statements on the academic integrity. So I encourage you to read through, make sure you understand everything and you abide everything that is stated clearly at the academic integrity. Also, we are still in this kind of COVID pandemic situation. So I understand, everyone may have some, difficulties or, maybe throughout the course. So, I will try my best to accommodate. So please, feel free to communicate with me. So if you have any special requests, I'll try my best to accommodate. But I should also emphasize this does not give you the excuse to not participate in the course. So I will still hold you accountable. Okay, so for the participation and the contribution to the course. Okay, and here's the structure of this course. So the first part will have I will have the lectures, maybe around 10 lectures, to cover a few key and trending topics for medical computing. For example, I will talk about the medical image processing, the basic imaging modalities, and some of the fundamentals, and also some of the image processing or computing tasks like classification, registration, segmentation, etc. Okay. Next, I will have a brief introduction to deep learning. So there's a student may not know a lot deep learning. So consider this will be a crash course for the deep learning. So introduction to the fundamentals of convolutional neural network, and also the most recent vision transformers, which gaining a lot of attention in the vision community. So I will also talk about that. And also talk about the medical image classification, segmentation, methodologies, mostly focused on deep learning based method, right? Because this is the trend. If you look at those MICAI, IPMI, those top conferences, you will see, I think, at least 80% of the papers, you will see deep neural network, the keywords, or deep learning, or some neural networks. They all have deep learning approach to complete all these different tasks. Okay, and we'll also talk about generative adversarial networks, their application in medical image analysis. One is the image synthesis, which I talk about when I mentioned the course assignment, right? You can using GANs are well known for image generation, right? So for image analysis, one scenario is that, for example, this patient may only have CT images. Is it possible to using GAN or train a GAN to generate the corresponding MRI images so that you have more information to do the diagnosis, right? So that's a very interesting topic in this domain. So which we'll also briefly talk about that. And we'll also talk about self-supervised learning for medical image computing, okay? For the deep learning, it is very data hungry, right? So we need a lot of label data. But for medical images, ask the physicians to label the data is very time consuming, right? So we don't have the luxury to have a lot of large scale data set, label the scale data set. But maybe we do have a lot of data without labels, right? So how can we leverage those unlabeled images or data to train your machine learning model that is able to build a very good representation for your task? So this is a very important topics. We'll also talk about that. We'll also talk about adversarial learning, robustness of the deep learning. Like I mentioned before, robustness is very important for deep machine learning in medical diagnosis, right? You don't want your model that is attacked by some malicious attacks, then your machine learning model suddenly fails, right? You make the wrong diagnosis. So that is, we will never see that, we don't want to see that happen, right? We'll also talk about the data privacy for the medical image computing, because a lot of all these data are patient data, so they have the privacy is the top priority. So we cannot share like, hospital A, hospital B data to the cloud and train a model there, right? Because then we have the privacy leakage there, right? So, but how we still able to learn the knowledge from the data from different sites? So that's one technology called the federated learning will provide. So we'll also talk about that as well, okay? So that's the first part. The second part will be the paper presentations. I will provide a list of papers that cover a wider range of topics, which may be falling into these categories. So each class will have a student presentation to talk about these papers and learn more and learn the latest tech in this particular problem. Okay, and the last part will be the project presentation. So that's towards the end of the semester. When you almost finish everything of your project, then we'll showcase your work. Okay. So the outcome of the course has threefold. One is, basically understand some of the fundamentals for medical image computing and know the state-of-the-art techniques for those image analysis tasks. From the lectures I provide and the paper reviews, okay? And the second is the hands-on experience on solving some medical image computing problems, right? Through the programming assignment, covering 3 different topics, and also the course project, which you have the freedom to, choose whatever project you want to do, okay? Maybe relevant to your research or maybe relevant to some of the topics you are interested in the future, maybe. Okay, and also, develop skills for conducting researches, right? So by paper reviews, paper presentations, and also project presentation and reports, right? So most of you are doing masters, some are PhDs, and some of you are eventually want to maybe pursue a PhD. So how to conduct high quality research is the essential skill for you to be successful, when you are pursuing the, PhD degree. So, so hopefully that's something you can, learn or develop from this course as well. Okay. Okay. Any questions so far while I talk about all these components? Any questions? See the chat. Yeah. So the programming, if you don't know anything about Python, it may be difficult because you have to learn Python first. But if you feel like you can do these deep learning project on other language, I think like Julia is also very popular right now. I don't know if there are people using Julia to do deep learning. MATLAB, I'm not so sure if you can do that. I think they have deep learning packages in MATLAB. If you know MATLAB, maybe you can give it a try. But preferably Python, and then you can learn those deep learning frameworks. So you're able to do the program assignment and project. But I provide those necessary resources for you. So if you follow those tutorials and some of the medical image tools I mentioned in the beginning, so they are modularized. So it's very easy to use. If you follow that, it won't be very difficult for you to get a hands-on on the programming projects. Okay. Yeah, no exam for this course. So I don't think, exam will be necessary because, for this course, the fundamental will be learning something useful, when you're actually doing something, right? So that's why I emphasize heavily on the programming, right? Project and assignment, okay. No, I said research papers is the ideal case, right? So if your final report, I see your method has something very novel, right? Maybe then we can discuss in detail, maybe something beyond this course, right? So maybe for this course, you have some method initial result, which I see, okay, there's some novelty here. Maybe it's something we can lead in towards publication. We can discuss about that later, maybe beyond this semester. We can work in the summer if you're interested, and eventually for publication. But the minimum is that when you finish the course project, you write a report, like the final project report. And so for me to review in term like a paper format. So I'll provide more details on that. But you're not required to publish a paper, okay? Okay, any other questions? Okay. All right, so how we are doing time? Okay, so yeah, I think we are running out of time. So, but maybe take 1 more minute just to give you like why we are interested in this course, like the motivation of doing this course, right? So first is, imaging science is, has a tremendous growing in the US and even in the globe. And so there's a lot of job opportunities when if you are going for this domain, right? And this biomedical imaging and its analysis are fundamental to a couple of things. One is understanding and visualizing, right? You see the physicians to, visualize those MRI scans, CT scans, and doing the diagnosis based on those images, right? And also we can using AI or machine learning technique to quantify some of the information, right? To help the physician to easily reach a conclusion. So that's what this is aiming for, right? Develop AI or machine learning technique that can automate these kind of analysis process. Okay, so, and well, also the last thing I want to emphasize is that for this course, we'll emphasize on analysis of these medical images using deep learning based method, because this is the trend in this domain, and a lot of field people already embrace deep learning because of the highly successful rates or their performance in many applications. Okay. So yeah, so that's it for today. So for the next class, we'll talk about how to review the paper, and I'll also go over some of the project ideas. So what is exactly you can select your topic and formulate a problem for your final project. Okay. All right. So let's see. It's an individual project. So yeah, I think, like a two-team project will be difficult to distinguish like each one's contribution. So I would rather individual project. So, kind of force you to learn more, okay? So this is an individual project. Okay. So yeah, if you don't have further questions, we're gonna stop here. So we'll meet again on Thursday, okay? All right, thank you everyone. Have a great day.